Good day, this is Mr. Morales. I'm going to go over page 51 and 52, I believe, on quadratic applications. So we're dealing again with projectile motion, which is just basically fancy science for saying, things that get shot up in the air and come back down again in some way. And we're back to our very common example of a diver. So we have a diver that's jumping from a diving board that's 32 feet above the water. The height of the dive is given by the equation f of t equals negative 16t squared plus 16t plus 32, where height is measured in feet and time is measured in seconds. So here's our graph. The graph was already given to us, and we're asked to complete the table of values. So that takes me to our first little calculator trick I want to show you today. So you can graph this equation. Just remember to change all the t's to x's when you graph it. And I already have my calculator set up. Now, if you notice this table, they want us to get the values over here for height, which I already have done. However, what you may not know is how to get the values for halves, for like half, 0.5, and 1.5 and whatnot. So I'm going to show you exactly how to do that now. In my calculator on the scratch pad, of course, I have the equation that was mentioned, and I changed all the t's to x's. So I'll go ahead and graph it. I'll press enter. When I do that, I get the graph, but I'm not really concerned about the look of the graph right now as much as I am about the table and the values. So I'll press Control and T to get my table. Now the table is counting by ones, as you can see over on the left-hand column over here. It's counting by whole number ones. What I want to do is go ahead and count by halves. To do that, you're going to press Menu, go to number 2 for Table, go to number 5 for Edit Table Settings, and then on this screen, what you're seeing is two options. Table start means what number, whenever it pops up a table for you, what number do you want to start at? And generally it'll start at 0, but you can set it to any number you want depending on how you're counting and what you're measuring. What we want to look at is the next selection down. So if you down arrow where it says table setup, it says 1.0. 1.0 means how do you want to count by on the table and on the x values. And a 1.0 means by whole numbers. So 1, 2, 3, -1, -2, that kind of thing backwards too, whole amounts. We want to count by halves because we want to measure halves. So I'm going to delete that out and type in 0.5. And don't worry about independent or dependent, and just down arrow to OK. And then now our table gives us the missing values. You can count by halves, quarters, thirds, whatever you want really, as long as you convert it to a decimal and put it in the field that was mentioned before. So here's how I got the values, and here's the table of values that we have. So the graph is all done for us. I went ahead and add some extra information just so you know that when we write coordinates from this table, T and H refer to time and the height in feet. So whatever numbers you have there, that's what they're measuring. On a table also, remember the x-axis is always your independent value and the y-axis is always your dependent value. And whenever you have time involved, time will always be your independent value for all intents and purposes. So just remember that. It's a really easy way to not get them confused with word problems. Time is always going to be your independent value when compared to something else. So let's go ahead and look at our first question. What does the independent variable represent? Well, that would be our t value or the x value, same thing, and that's measuring our time in seconds. Next question is, what does the dependent variable represent? That would be our height in feet, and it's already labeled for us, so all you have to do is basically just copy down what the graph is already telling you. I mean, your work can't be any easier. Let's go on with the next questions. Then it goes, what is the y-intercept? The y-intercept is wherever the graph meets the y-axis. So I went ahead and first listed the coordinates. That would be at 0, 32. And then I explained what it means, because that's what we're asked to do. What is the real world meaning? So in a brief sentence, when time is equal to 0 seconds, the diver's height is 32 feet. You could also refer to it as maybe the diver's initial height is 32 feet. However you want to explain it, as long as you have 0 seconds mentioned and the 32 feet for the height mentioned in your statement. Moving on for part E. What is the x-intercept? The x-intercept is wherever your graph hits the x-axis. In this case, right here at 2. So at 2, 0, I describe it as at 2 seconds, the diver's height is 0. And in other words, in terms of the story, the water's surface. So you can say maybe the diver splashes through the surface of the water at 2 seconds, which is 0 feet. However you want to mention, as long as 2 and 0 is also mentioned in your explanation, because that is what's being represented by this coordinate. Moving on. What is the vertex? The vertex is always your highest point or your lowest point of your parabolas. And in this case, our vertex is right up here. When the diver first jumps up, they hit a maximum height before gravity takes over and pulls them back down. And that would be at half a second, the diver reaches 36 feet. 0.5, 36, and I just said that again in sentence form. So this work is basically kind of just saying it in math numbers and explaining in a sentence. So it's a little bit of a writing assignment, nothing you can't handle. Part G, when will the diver hit the water? This is not only a measurement of time and height, but it's also pretty much an equal measurement of what is happening to the diver. So we can see the diver hits at 2 seconds. The diver will hit the water at 2 seconds. Maybe hit's not the word you want to use. Make contact with the water surface, whatever you choose, as long as you mention the 2 seconds. Excuse me. And then finally, we have some more questions. Find the value of f of 2. That means when you plug in a 2 into this equation, or in other words, in 2 seconds time, what is our height? Our table tells us at 2 seconds, our height is 0. So f of 2 equals 0. What is the value of t, or when f of t equals 32? So basically, at what times do we get a height of 32 feet? We get those two heights at 0 seconds in the very beginning, and also again at 2 seconds, at 1 second after the diver initially jumped off. So at 0 and 1, which you would write in set notation, not in parentheses like it's a coordinate. J down here, describe the domain. Since this is a real-world scenario, nothing's happening infinitely in this case. So the domain is everything on the x from 0 to 2 seconds and all units of time in between. So we have the equal sign also there. Our range behaves the same way. It's from the lowest height ever reached to the highest height ever reached. Well, the lowest height we reach is at the end of this trip when the diver makes contact with the surface of the water. So that would be 0 feet. And the highest would be our vertex way up here when the diver jumps up and hits his maximum height at 36 feet. So everything from 0 to 36. Do not get these two confused. I did notice on some past questions, a lot of students will always go left to right here, which is great, but then they want to go from top to bottom over here on the y. Remember, it's always from lowest value to the highest value. Lowest value to the highest value when you're measuring those things. So let's go ahead and turn our page over and do the next set of notes. So on the back, it's pretty much the same thing. Now we have something that's a little more like CSI. The stopping distance, d, in feet of a car traveling on dry pavement is given by the formula d equals 1.1 s plus 0.05 s squared, where s is the speed of the car. So what this is describing is when you're driving in a vehicle, and all conditions being normal, a dry road, in other words, dry pavement, and you apply the brakes, your car does not instantaneously stop. It has to travel a little bit because of momentum and inertia. So what's happening in this case is that we've actually been able to calculate, scientists have,